Hi everyone, I'm Gunushri studying in Sri Venkateswara College of Engineering. Today, I'll be taking up the subject operating systems. I'll be discussing about the topic memory management in operating system. So what is memory management? So it is one of the crucial function in the operating system that will involve the managing of the primary memory, that is the RAM, and also the secondary storage memory efficiently. It is also responsible for allocating memory to process, ensuring each process will have enough memory to execute and freeing up memory when it is no longer needed. Memory management will play a very important role in preventing memory loss, leaks, fragmentation, and also ensuring the overall system stability. What are the key objectives of memory management are? First thing, it has to efficiently allocate memory to the processes to maximize the system performances. It has to protect memory space of one process from being accessed by another process. It should also optimize memory usage to prevent wastage and fragmentation of data. Moving on to what are the types of memory management. It is divided into two types, that is contiguous memory management scheme and non-contiguous memory management scheme. Contiguous memory management, it will assign a single block of contiguous memory to each process. Partitioned memory management is a second type, in which the memory is divided into fixed size partitions and processes are allocated memory based on these partitions. Paging, memory is divided into fixed size blocks called pages, and processes are divided into fixed size block called frames. Moving on to memory allocation strategy. So what are the different things? Then majorly there are three different things coming up in memory allocation strategies. One is the first fit, best fit, and the worst fit. What is first fit? It will allocate the first available block of the memory that is large enough to accommodate the process that will be giving as an input. Best fit, it will allocate the smallest block of the memory that is large enough to accommodate the process. Worst fit, it will allocate the largest available block of memory to the process. Moving on to memory fragmentation, there is something called external fragmentation and internal fragmentation. External fragmentation, it will free the memory blocks that are scattered throughout the memory, making it challenging to allocate contiguous memory to process. Internal fragmentation, it will occur when allocated memory is slightly larger than the requested memory, leading to wasted space within a block. Moving on to what is memory compaction. It is a technique used to reduce the external fragmentation by rearranging the memory blocks to create a larger contiguous free memory blocks. It involves moving processes around in memory to consolidate the free memory blocks and also to reduce the fragmentation. Memory compaction is essential for maintaining the optimal memory utilization and system performances. The next important topic is swapping. So it is again one of the memory management technique, which will involve moving an entire processes between the primary memory and the secondary memory. This will occur when the system will run out of available memory. Then the operating system will swaps out less frequently used processes to create space for the new processes that will be entering into the operating system. Swapping will help to prevent memory exhaustion and allows the system to handle more process that can fit in physical memory. Demand paging. Again, this is also one of the memory management technique that will load pages into the memory only when they are needed by the process. It will allow the operating system to optimize memory usage by loading pages on demand, reducing the overall memory footprint. Demand paging will also help in improving the system performance by minimizing unnecessary page loads and reducing memory overhead. Moving on to memory protection. So again, it is a mechanism that will prevent one process from accessing or modifying the member space of another process. It ensures that each and every process will have its own isolated memory space, also enhancing system security and stability. Memory protection mechanisms will include hardware enforced boundaries and also access control lists to restrict unauthorized memory access. Virtual memory. Uh, Another technique that can also be used to manage the memory in the operating system effectively. It will allow the operating system to use secondary storage as an extension of the primary memory. It will create an illusion of a larger memory space by swapping pages between primary memory and storage as needed. It will also help to improve the system performance by reducing the dependency on physical memory and also enabling the execution of larger processes. Next is the memory mapping. It is a process that will map the virtual memory address to physical memory addresses. It also processes to access and manipulate memory addresses in a consistent and efficient manner. It will simplify the memory management for both the operating system and applications. Also, it will enhance the system performance and usability. Memory paging. In this particular technique, they will divide the memory into fixed size block called pages. It will allow the operating system to allocate memory in a smaller increments and manage memory more effectively. It will help to reduce the external fragmentation and optimize memory usage by organizing memory into uniform blocks. Next is the memory segmentation. In this technique, the memory it will divide the memory into variable size segments based on logic units such as code, data, and stack. It will allow processes to access different segments of memory independently. It will also enhance the memory protection and organization in a better way. It will help to improve memory management flexibility and efficiency by grouping related memory segments together. Next is the shared memory. So it will allow multiple processes to access a common memory space. It enables the inter-process communication and data sharing between processes to happen in a very effective manner. It will also improve the system efficiency and collaboration too. It is commonly used in parallel computing and multi-threaded applications to facilitate data exchange and synchronization. Next is the memory leak. This will occur when a program fails to release allocated memory after it is no longer needed. So proper memory management practices like deallocating memory when it is no longer in use are essential to prevent these type of memory leakage. Garbage collection. So it is also a memory management technique that automatically deallocates memory that is no longer in use. It involves identifying and reclaiming unused memory blocks to prevent memory leaks and optimizing memory usage. Advantages are it will create objects when needed, and when it is not in need, it also deallocates the spaces and no need to specify the destructures and other special memory considerations. It is there is a minimum leakage of memory and there are no dangling pointers present in the garbage collection. Memory monitoring. It will involve the tracking and analyzing memory usage patterns to identify the inefficiencies and potential issues that will be occurring. So these memory monitoring tools will provide real-time insights into memory utilization and aid in maintaining system stability and efficiency. What are memory protection violations? When memory protection violations will occur when multiple process attempts are made to access unauthorized memory locations or to overwrite a protected memory. Mechanisms such as segmentation faults and access control list will help preventing unauthorized memory access, and also it will ensure the system integrity. Moving on to the conclusion. So I try to cover all the different topics that will be coming into what are the memory management techniques, how it can be used. So memory management is one of the critical component of operating system that governs the allocation, protection, and optimization of the memory resources that are present in the system. These effective memory management strategies such as memory paging, swapping, memory protection, fragmentation are very most essential for maintaining the system stability and performances. By implementing robust memory management practices, memory management techniques, operating systems can enhance memory utilization, preventing memory-related issues, and also to deliver a seamless computing experience to the user. Thank you for watching.